last class we have done the extensive use of departure function for delta H and delta S. We just started. So what we said, just to have a summarize, when you calculate delta H, delta U, delta S, whole lot of series, and P1 is the initial point, we are going P2 to P, and if you look at, this is the point, P1 to P1, or you can say P1 coordinate wise, P2 P2, and this is the thermodynamic path, but this will not work because we don't know the Cp except P tending to 0. That means if one would like to have the delta H for this, we first go P1 to P2, rho H by rho P at P1 dP plus we get T1 to T2, rho H, rho P, P2, dP. Right? This part is okay because we can write this as P1 to P2 V into 1 minus beta T P1 dP. That you can work on in the equation of steps. This part was T1 to T2 Cp at P2 D, that we don't know what is Cp at P2. Okay. So how to get Cp at P2, that we never thought about. One attempt would be, you can use this formula, dou Cp by dou P at fixed T, which is minus T dou 2V by dou T square at fixed T. And if you integrate dCp, which is Cp1 to Cp2, which is minus T dou 2V dou 2 square P, which is P1 to P2, which is dP. You can write this, right? Yes? And this will give you Cp2 minus Cp2. Again, you have to know Cp1 to get Cp2. If you know Cp2, this problem is solved. Cp1 is again in the real gas regime. If P1 is tending to 0, then you know Cp1. That means if your P1 is tending to 0 to P2, then you can apply this, no problem. Because once you get Cp1, you can get Cp2 from this formula. Correct? Once you get Cp1, you can get Cp2 from this formula. But the thing is, Cp1 can be known if it is Ig. Cp1 can be known if Cp1 Ig. That means if P tending to 0, P1 tending to 0, then only you can actually have, otherwise you cannot. Okay? So that's why we didn't accept these two steps. Two steps are not accepted. Then you wait for the three steps. We wait for the TP plane and TV plane. So when you go for the temperature and pressure plane, and this is your P1, T1, T2, T2, you went to the P tending to 0 path, then going there and going there. Three-step process. So that this vertical strip, that was a problem here. This thing will come the vertical strip. If I go to the vertical strip, just remember, very important point. The vertical strip should be around the P tending to 0 because that will give constant pressure and that will give Cpig at tending to 0. So horizontal point, horizontal lines you don't care. Vertical line only you care because that will be giving directly parameter like Cp or Cp, whatever. So Cpig can be obtained for P tending to 0, and we could get delta H, and delta H the formula we got minus H minus H Ig T1 P1 plus integral T1 to T2 Cpig dt plus H minus Hij T2. Right. So introduce the concept of departure function. So if I do that, one advantage is for the horizontal strip you get a generalized formula. For the horizontal strip you get a generalized formula. And this generalized formula for the horizontal strip, this strip or this strip, via the departure function. So by going to the third step, we are getting the Cpig into term cleared. Not only that, we can get this horizontal strip as along the constant temperature path. Along constant temperature path, we can have the introduction into the concept of thermodynamic departure function. And we found that for delta H, so there are two ways you can actually analyze the delta H. You can calculate delta H, one in TP plane, another in TV plane, where the path will be like this, and then come here, and then come here. And this is, as I said, this is your V intensity. If you go by this, you will get the formula delta H was minus H minus Hij T1 V1 plus integral T1 to T2 Cpig dt plus H minus Hij T2 dt. We found not only the departure functions are same in TP and TV plane, but the delta H has to be same. It has to be same. Whatever the departure function is, delta H is the change in enthalpy. Enthalpy is thermodynamic property. Doesn't matter which path, which variable you take, it will remain unchanged. It will remain unchanged. Okay. So we found both the approach, TP plane and TV plane, give the identical results. Okay. So I think up to that everything was okay, right? So next we have started talking about the change in entropy. Talking about the entropy, change in entropy. So let's look at that part. Remember that the departure formula for any thermodynamic property, M minus Mig Ti Pi, which is P tending to 0 to Pi, dou M by dou P Ti dP minus P tending to 0 Pi dou Mig by dou P Ti dP. Right? And we found that the second derivative going to 0 for the enthalpy. That's what the formula was so straightforward for H minus Hij. But for the entropy, both these terms will be important. For the entropy, both these terms will be important. Eventually, in the last class, we concluded the formula of delta S, which is minus S minus Sij T1 P1 plus T1 to T2 Cpig by T dt plus S minus Sij T2 P2 plus other term or minus other term, whatever. Plus or minus other term plus RLN P2 by P1. Am I correct? Yes? Minus, okay. no problem. This formula is valid for the real system. If you say, sir, P1 tending to 0, this formula is not valid for P1 tending to 0, it's for real system. If P1 tending to 0, then you have to start from first principle and see what you get. You don't have to go by this path. You have to go directly 2 steps. If P1 tending to 0, directly 2 steps. If P1 not tending to 0, 3 steps. So therefore that means if P1 tending to 0, you can say that this formula will not work. This formula is valid for the 3-step process. If P1 tending to 0, why will go for 3 steps, only 2 steps? Right? The thing is that delta S in TP plane must be equal to delta S TV plane. No question, no doubt, no confusion, thermodynamic property, which is entropy is a thermodynamic property. No question, no doubt, no confusion. The question is, departure function S minus Sij Ti Pi is not equals to S minus Sij Ti Pi. They are different. Earlier we proved departure H minus Hij Ti Pi equals to H minus Hij Ti Pi. It was proved. But here we will be showing that S minus Sij Ti Pi will not equal to this, even that delta STP equals to delta STP. Right? Even that delta STP equals to delta STP. Right? So let's proceed for the calculation or the final formalism of S minus Sij Ti Pi. Okay. So let's look at the formula and start deriving from the first principle. So S minus Sij Ti Pi. What should I write? S minus Sij Ti Pi. What should I write? Who can volunteer? S minus Sij Ti Pi equals to, next step. Integral, don't say. Integral P tending to 0. Pi. Dou S by dou P. Ti dP minus P tending to 0. Pi. Dou Sij by dou P. Ti dP. Very simple. No need to think much. And dou S by dou P at Ti. Next step. This expression was there earlier. What is that? Dou S by dou P at fixed Ti. It was in the Maxwell's relationship, right? What is that? Minus dou V by dou T at fixed P. Minus dou V by dou T at fixed P. It's Maxwell's relationship. Please look at it. If you don't remember, look at that. You look back on your notes. You can get it. So minus P tending to 0. Pi. Dou V dou T fixed P dP minus P tending to 0. Pi. What should I write? What should I write? Dou Sij by dou P minus R by P dP. Minus R by P dP. If you look at the function of V is the function of P and T. This derivative suggests, right? And this is also function of, if you look at function of P and T. Point is, once my friend mentioned that, I am referring to him, beautiful question he asked, I remember all the time, teach departure, my second lecture, we have departure. And he said that it won't work, right? And your point is very, very valid, because P tending to 0, R is constant, it will be ln Pi by P0, oh, dangerous. So, that suggests that in departure, whenever you have the integral, you should not do anything in P plane. You should do anything in P plane. That suggests that whenever you do departure calculation, departure integration, any integration comes out, when you have any departure formula, any property you take, thermodynamic property, you want to find out departure formula. Never ever go to the pressure plane. You are not writing anything. I think only few people are writing what I am talking. This is not available in the books. Doesn't matter. Whoever is interested will write. So never ever you take the integral in P plane, because that will give the integral which cannot be obtained, and of course V plane is the next possible step. So I will take the first integral, this is the first integral, and the second integral. And by now you have some idea how to evaluate. So first integral is minus p tending to 0 pi dou v dou t at fixed p dp. And I cannot evaluate this unless I convert to the v plane. So what will be my next step? What will be my next step? What will be my next step?
Implicit.
Not implicit. dp you have to first express in terms of dv. Just like that, don't apply the formula, apply your brain, apply from the heart. You should not think about mathematical manipulation. If I'm looking at it, I can see that first this guy has to be dv, then other terms. Otherwise my integration cannot be fulfilled. And if I want to go to this, I have to first put v tending to infinity to vi, the first step. Next step, this guy has to be converted to dv. How to do it?
dp by dou p by dou v.
Dou p by dou v into dv. So dou v dou t p dou p dou v into dv. Now this is the function of v, but it's still the function of p and t. Every term you just see what is there, how to approach. The function of p and t, the function of v function is v already. So this guy you have to do some replacement. Of course we have implicit function theorem. You can apply implicit function theorem. Next step is v tending to infinity vi minus dou p dou v dou t. What you will get? Minus will go because minus is already there.
Dou p by dou t at p by dou p.
Dou p
by dou t.
Dou p at v
By dou p by dou t at p.
dou p by dou v at t, dou p by dou v dv, and this is this departure calculations always we can actually do the constant temperature part, and this goes to cancel for the constant temperature part. Okay, constant temperature already maintained because you know the departure calculation temperature is always constant. So we have v tending to infinity vi dou p dou t v dv, and if you look at this function which is p hat bt dv, this is acceptable function, acceptable integral. Every term you have to check, go check, so you can get the results. So first integral is solved. Second integral, which is minus p tending to 0 pi r by p dp, and this is the function of, say, function g hat p. So again next step will be v tending to infinity vi. Who will do the next step? First we have to replace dp by dv. How? Dou p by dou v into dv. Dou p by dou v into dv. We have r here 1 by p. How to do next step? How to do? 1 by p dou v. How to approach it? Next step. 1 by p dou v. This course, if you are good in calculus, this course will be easy. If you are not good in calculus, this course is difficult. This is based on completely. Some people ask me, what is the application of calculus? And I told the application is advanced chemical in thermodynamics. Okay, so you can see that. How to replace by the calculus? Because 1 by P dangerous, we cannot do anything here. To do something here. You can do something, you can use something here. So what you do? Minus R. At this point you cannot do. See, now see that it looks so simple. It's so difficult to develop. Looks so simple. Minus R by PdP, nothing. It's so difficult. How to do that? 1 by P, dou B. ddx of ln x equals to 1 by x, right? Am I correct? ddx of ln x equals to 1 by x. I get the hint. Now can you tell me? What should I write? V tending to infinity to Vr. What should I write? One hand, please. One hand. You may be wrong, no problem. By doing mistakes, we learn. Yes, last bench. Dou B of? Yes. Dou B of ln P dV. Am I correct? Yes? Yes? Yes or no? Correct? This ln P, delete this part, minus R, V tending to infinity, Vi, dou B, we can write ln PV minus ln V dV. So I can write P as PV by V, ln A by V is ln A minus ln B. Am I right? ln P is nothing but ln PV by V. ln A by B is nothing but ln A minus ln B. Right? Correct? Okay. Next. Now we can see situation is not that difficult at all. V infinity to Vi, dou V ln PV dV plus R V tending to infinity Vi dou V ln V dV, and both the case this will go and you get differential of ln PV, and another case you will get differential of ln V. First case you get minus R ln Pi Vi minus ln PV at V tending to infinity, which is nothing but PV at, pardon? RT, yes, minus ln RTR, because T is fixed just here, right? Minus ln RTR plus R differential of ln V. What should I write? Differential of ln V. How to evaluate? Differential of ln V. Differential of ln V. V tending to infinity, Vi, some beautiful formula will come. Differential of ln V. I am just trying to test, your calculus knowledge. I am not happy with you. I am not getting so far good answer except one or two. Differential of ln V. What should I write? Differential of ln V. Any idea?
1 by K dV.
Yes. Very simple. That's all. Differential dV by V. So Pi Vi is Zi RTR, right? So it is nothing but ln first term will be minus R ln mod Zi RTI by RTR. RTR will cancel, you get Zi plus R V tending to infinity Vi dV by V. So now we get the final form S minus Sig Ti Pi. S minus Sig Ti Pi equals to, we will give the final form. I think this term is plus. Check it out. So then this will be minus. Second term is minus. Okay. Please correct it. Am I correct now? Okay. Yeah, so can you give me the, now we will see that whether you got the sign everything correctly. I want the final expression of the S minus Sig Ti Pi. There are only two expressions. One is in terms of compressibility factor, another is within the integral dV. That's all. There will be two expressions. 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 S minus Sig Ti Pi. You can, so simple. Everything is there on the board. You have to just tell me from the board. That's all. So simple. So simple. Just to tell me two terms from the board. You don't have to do anything. You don't have to do anything. Yes.
Integral V.
Now first you tell in terms of Zi.
R log Zi.
R log Zi.
Minus.
I think this will be plus. Yes.
Plus minus.
Okay.
R integral.
Plus.
Minus R.
Minus or plus?
Minus.
Okay, I write plus. Then how to write?
Integral.
Only this much will be there, no other term. Only this by the two terms. If I say plus, it's possible to do it. There were only two terms, no three terms. Because first integral will give you only the integral V plane. Second integral will give one V plane integral and the Zi term. That those two V integral can be combined. You have done it for H, delta H. I am surprised that none of you could understand what I did last class. Delta H. H minus Hig Ti. So simple calculus derivation. So simple. Yes, madam. Got it? Yeah.
Dou P by dou T and constant.
Dou P by dou T at constant V
Minus R by T.
minus
R by T.
ER. Over. So simple. So this is the departure formula for the TP plane. Okay, you keep it. This is very important. This formula will be required when you compare the expression for S, delta S for TP plane and delta S for TV plane. Now we will go to departure formula in TV plane and we will show that both are not same. They are different. S minus Sig Ti Vi tending to infinity, Vi dou V, V tending to infinity, Vi dV. Advantage of TV plane is already in V plane. It's already there in V plane, so you don't have to do much juggling for the integration. Then point is then why you don't work in TV plane, why you go for TP plane? Because temperature pressure is easily available, easy to measure. Volume difficult to measure. Volume very difficult to measure because there will be some kind of container like this. Gas will be there. If you put some pressure, barometer or something, you can get pressure easily. To calculate volume, you have to do very difficult job. It's not even I don't know how to do the volume calculation. So T and P is easy to measure. That's why you always go for TP. If you get V knowledge V, then no problem. So regular domain V, then no problem. So that's why although V integral is easy, but we cannot do it. So what to do? Dou S dou V at fixed Ti dV and dou S Ig dou V Ti dV. How to approach? Vi tending to infinity. Vi, so V tending to infinity should be dou S by dou V at fixed T. It is available from any of the relationship earlier. Maxwell's relationship. Dou P by dou T at fixed V. Dou P at dou T at fixed V dV minus V tending to infinity Vi dou S Ig by dou V at fixed T was obtained as any expression for Ig. We have done it earlier. Dou S Ig by dou V at fixed T. What you got earlier? Dou S Ig by dou T at fixed dou V at fixed T. What you got earlier? Pardon? R by V. You can see everything is obtained. We don't have to do anything else. If you look at S minus Sij Ti Pi, this integral is already there. You got the extra term S minus Sij Ti Pi. Right? You have got the extra term. That's it. You have got the extra term. But others are saying. Beautiful. That means it shows S minus Sij Ti Pi not equals to S minus Sij Ti Vi. Good. They are not the same. Okay. Next task. To prove delta STP equals delta STV. Departure formula different. Agreed? Yes or no? This is very straightforward. Nothing is there for the TV plane. Okay? So TV plane, nothing is there. Now, if I want to write delta S TV, what will be my formula? Minus. Yes, madam, please. Minus S minus Sij T1 V1 plus integral T1 to T2 then? No. What is that? No, CVIG, no, it's an ideal path, ideal gas path. Ideal gas path is ideal gas path. What will be the term? CV IG by, don't say CV, CVIG by dt, because this thermodynamics is not like some mathematical term. You have to feel for that. If you don't feel, then no problem. Because you know you will somebody will learn wrongly if you say something wrong. Okay? CVIG dt. Am I correct? Or if you want to write properly, I can write it for you. I think you want to write properly. Okay. So I think you are not comfortable with this. So it is dou S by dou T at V tending to infinity dt plus S minus Sij T2 V2. Next term. Next. This is not the end of the story. There will be another two terms. If you want me to do the from the very basic, I can do that. Good for you, good for me, no problem. Very basic I am doing. Delta STV. Very basics. Remember that there was the integral here, which was P1 to P tending to 0, dou S by dou P at T1 dP. That I replaced by departure. So there will be some extra term for that. Try to feel thermodynamics from your heart. Otherwise it will be difficult for me to teach. I will be helpless. Feel for it, you get the terms. You don't have to remember anything. I don't think you feel for that. Yes. Yes. Integral. Tell me in terms of integral. First integral will be, there are two integrals, right? Yeah. First integral will be minus or plus?
Plus.
Plus, are you sure?
Minus.
No. First integral will be coming from here. Second integral will be coming from there. First integral will be minus or plus. This kind of confusion was there in last class. I clarified. Yes or no? You didn't get it? My God, that means every day I have to repeat previous day's class. So my displacement will be 0. M minus Mig Ti Vi. What formula will be there? From very basics. Pardon? No, you don't write integral. Integral V tending to infinity to Vi dou M by dou V Ti dV minus V tending to infinity Vi dou M Ig by dou V Ti dV. How this term came? Before that, I think I have to write everything in details because you have no time to study. So I will help you if you don't have time to study. Dou S dou V T1 dV. This term will be V tending to infinity. Vi to V tending to infinity. This is V tending to infinity to, it should be V1, it should be V2, dou S by dou V T2 dV. Am I correct? Yes or no? This one? Yes, agreed. Now can you tell from the departure? This term will be equals to this plus this, but this is minus departure. This is actually V1 to V infinity. So if you write in terms of this kind of integral, which is V tending to infinity to Vi, so already this minus term. This is already in terms of departure kind of formula. Departure integral is, when you talk about departure integral, is infinity to something, not something to infinity. So that's why it's minus. So if this is the integral you have to get, change the sign, this will come here. What will you get, madam? See, so much of hard work I have to do if you don't study at home. I get sweating, fine, but thing is that I don't know whether my sweating is somewhere. Yes. Minus Sig. You are only talking, she is not talking. That means still you are not convinced. Yes or no? I am just asking. G T1 then plus, because this integral is minus. Here this is the minus term, right? So if I put minus here, it will be plus, it will be minus. So I am trying to equate that. So I have gone to the kindergarten level to this thermodynamics. I am going to kindergarten level. That's good. So I should know how to teach thermodynamics to a kindergarten kid. Okay? Plus T1 to T2 dou S by dou T is ideal, right? V tending to infinity. What is that? Cvig by T dt plus S minus Sig T2 V2. So this term, extra term will be minus V tending to infinity Vi dou Sig by dou V T1 dV. Am I correct? Yes? T1, yes, you are right. Okay. Next term, from here, what will you get? Plus V tending to infinity Vi dou Sig by dou V T2 dV. Am I correct? If you don't study, again I am saying that the person suffers. Who suffers? You know, you don't. I suffer. Right? Why I suffer? Because I wanted to get good grade. If you don't learn here, you get bad grade. It is teacher's discredit, not your discredit. Always I find students the best. So there, it is our duty to teach them. Okay. What is this? Dou Sig by dou V T1. Dou Sig by dou V. What is that? You have already your formula handy with you. So we will have the final form delta S. We will have the final form delta S we'll have the final form delta S. We'll have first term minus Sij T1 V1 plus integral T1 to T2 dou S Cvig by T dt plus S minus Sig T2 V2, and then two integrals combined will get both the integral, you get R by V. So V infinity will be cancelling like last term, P turning to 0, you will get a cube term plus what did you get? Plus what did you get? Plus what did you get? Please raise the hand.
V1 to V. Integral V1 to V.
What? Integral to V1. Can we write like that mathematics? Yeah, if I talk like that, you will say teacher is a lousy teacher. That's what. If I say integral V1 to V2, you get something like that and go. I cannot talk. I have to be careful because my duty to make you understand. I have done the similar kind of thing in the last class of delta S. It is so unfortunate. Please, when I come to you, unfortunate that I am not getting the answer. Yes, madam. Yeah, R ln V2 by V1 is so simple, and I was struggling to get that answer. Plus R ln V2 by V1. So simple. Okay, so now what do you need to calculate? So this is your delta S TV. So now if you look at delta S TP formula, TV formula, both are next to each other. And of course, it is not obvious they are same. Because this term is different, this term is different, this term is different, this term of course they are different. It is not obvious they are same. How to prove they are same? How to prove they are same? So we'll go for delta S TP. We'll go for delta S TP. Delta S TP, which is minus S minus Sig T1 P1 plus T1 to T2 Cpig by T dt plus S minus Sig T2 P2 minus R ln P2 by P1. From here we got minus R ln Z1 mod. If you look at departure formula, S minus Sig Ti Pi departure formula is R ln mod Zi plus integral V tending to infinity to Vi dou P dou T V minus R by V dV. Correct? So you got minus V tending to infinity to V1 terms will be, what is the integral term? What will be a term? I am really surprised that everything is known to you and not able to tell me. I am really surprised. Please one hand please. You are, yeah. Yes, that's what. I am not asking something difficult. I am asking which is available to you. I am not asking anything you have to do because I am really surprised that whether my teaching is so bad you are not able to follow. I am really surprised. But anyway, at least one person is telling I am happy. Dou P by dou T V minus R by V dV. Okay. Next, we cannot do much. T1, T2, Cpig, T dt. Next, plus this term. Who will volunteer? This term, what will be the term? Any hand please? S minus Sig T2 P2. Who will volunteer? Yes, sir. No, not you. You are doing every time. Anybody else? I am really surprised. In the entire class, you cannot volunteer S minus Sig T2 P2. Only one person. I am really surprised. Yes, yes, sir. R ln mod Z2. Yes, sir. Plus integral V tending to infinity to V2 dou P dou T V minus R by V dV minus R ln P2 by P1. Nothing. I am not doing anything. I am just doing everything is available. I am surprised that not only one or two guys actually would respond. That too, everything is available in notes. Okay. This is my integral I1. This is my integral I2. Remember that these integrals will also appear for TV plane. That's why I am actually separating out. TV plane also will get this kind of integral. I will show that. If you look at TV plane departure function, this term is not there. Only this term is there. You have to feel thermodynamics. It is not a mathematical manipulation. If you do mathematical manipulation, you are lost. Every term you should feel what it is coming, why it is coming. Similarly, for this term of the TV plane, this term will not be coming. Only this term will be coming. Okay. So, apart from the I1, I2, what you do get? If you combine these two, you will get R ln Z2 by Z1, then integral T1 to T2 Cpig T dt minus R ln P2 by P1 plus I2 minus I1. Yes? Yes? Delta STV. Or you can directly write, if you do one more approximation, not simple. So Z2 is what? P2, V2 equal to Z2 at P2, right? So Z2 by Z1, you can write as R ln, what you can write in terms of pressure, volume, temperature? V2 won't be as Z2. Okay, so you can actually combine these two. If you combine, what will happen? R ln Z2 P1 by Z1 P2. Am I correct? What will you get then? Combining these two, what will you get then? If you combine Z2 P1 by Z1 P2 or Z2 by P2, what will you get? In terms of V and temperature you will get, right? In the numerator, the numerator will be what? V2 T1 by V1 T2. V2 T1 by V1 T2. Okay. Plus T1 to T2 Cpig by T dt plus I2 minus I1. Simplified. Delta STV plane. What did you get? You have this integral terms, right? From here and here, the same. Integral terms are there. So we already have I2 minus I1. Am I correct? That coming from departure. I2 minus I1. So I2 minus I1 directly coming from departure formula for the TV plane. So this and this contributes I2 minus I1. You have extra terms R ln V2 by V1 and then T1 by T2 Cbig by T dt, and you can write this as Cp minus Cv equals to R. For ideal gas it is Cpig plus R or minus R? Minus R. Cpig minus R by T dt. Okay? So you have from here R dt by T, which is R ln T2 by T1 minus. It will be combined here. What will you get? R ln V2 T1 by V1 T2 by T plus T1 to T2 Cpig T dt plus I2 minus I1 delta STP must be equals to delta STV. Thanks for your kind attention.